Today we're going to talk about a hidden cost inside many Australian industrial and commercial facilities. It is not your supply chain, it is not labour, it is not raw materials. It is the quality of the electricity powering your operation. Poor power quality is often invisible. However, it can quietly erode reliability, efficiency and profitability across your entire site. Across industries such as food processing, utilities and logistics, facilities are becoming more automated and more electrified. You have invested in robotics, variable speed drives, high efficiency plant and digital control systems to remain competitive. Yet the same equipment that improves productivity can introduce a hidden inefficiency into your electrical system. That inefficiency often sits undetected while it steadily increases energy losses, stresses infrastructure and shortens asset life. That hidden issue is harmonic distortion. In simple terms, harmonics are distortions in the electrical waveform caused by modern electronic loads. Your electrical infrastructure was designed for a smooth sinusoidal waveform. However, non-linear equipment such as variable frequency drives, robotic systems and switch mode power supplies distort that waveform. The result is unnecessary electrical losses and system stress. On the right, you can see clean, stable power. This is what your transformers, cables and motors were designed to operate on. On the left, you can see distorted power. That distortion is created within your facility by drives, automation systems, HVAC systems, and increasingly even LED lighting and charging infrastructure. As electrification increases, distortion increases with it. This is not simply a technical detail for the switchboard room. Harmonic distortion has measurable operational and financial consequences. Left unmanaged, it increases risk, waste, and long-term cost exposure. Distorted power causes transformers and cables to overheat. It contributes to nuisance tripping of protection systems. It increases mechanical stress on motors and critical production assets. Over time, this leads to higher energy consumption, rising maintenance costs and premature equipment failure. For operations leaders, it increases the risk of unplanned downtime. For finance leaders, it inflates operating expenditure. For ESG leaders, it represents avoidable energy waste. Industry research reinforces this reality. Harmonic distortions are increasingly recognised as a driver of reduced asset lifespan and higher energy costs. In other words, this is not just an engineering issue. It is a strategic issue that affects resilience, cost control, and long-term value creation. If modern electrification has introduced the problem, intelligent system optimisation provides the solution. The goal is not to replace your infrastructure. The goal is to optimise it. One proven solution is the Active Harmonic Filter. An active harmonic filter continuously monitors your electrical waveform. It detects distortion in real time. It then injects an equal and opposite current to cancel that distortion. The effect is similar in principle to noise-cancelling headphones, but applied at an industrial power systems level. First, the active harmonic filter measures current and voltage waveforms. Next, high-speed processing calculates the exact compensating signal required. Finally, the system injects that signal back into the network. The distortion and the corrective signal cancel each other out. As a result, the system restores waveform quality and reduces electrical stress across connected assets. Traditional passive filters were designed for fixed, predictable loads. However, modern facilities are dynamic. Production lines ramp up and down. Robotic systems vary their duty cycles. Electrification continues to expand. Passive solutions cannot adapt to these changes. Active harmonic filters, by contrast, respond dynamically in real time. They support flexible, automated environments without constant retuning or redesign. This brings us to the business case. Power quality optimisation is not simply a compliance exercise. It is a measurable efficiency opportunity. Improved waveform quality reduces wasted energy. It lowers thermal stress on transformers and cabling. It extends asset life and reduces reactive maintenance. It can also reduce exposure to utility penalties linked to poor power factor or distortion. Most importantly, it reduces the likelihood of costly, unplanned outages. For many medium and large facilities, the return on investment is clear and defensible. Modern active harmonic filters can reduce harmonic distortion by up to 97%, subject to system conditions and correct sizing. That level of correction significantly improves system performance and stability. Even after accounting for the energy consumed by the filter itself, facilities often see a net energy saving of between 2 and 7%. Across energy-intensive manufacturing or infrastructure operations, that translates into meaningful cost reduction. For finance leaders, it strengthens the investment case. For ESG leaders, it delivers measurable efficiency gains. Projects such as the Snowy Hydro 2.0 have implemented active harmonic filters to improve power quality. They achieve lower energy costs, improve voltage reliability, and reduce power demand. These outcomes demonstrate that power quality optimisation delivers real operational value. However, this is not only about solving today's issues. It is about preparing your facility for tomorrow. Industrial sites are becoming more electrified. Automation is increasing, distributed energy resources are expanding, electric vehicle charging is being integrated into operations. Each of these trends introduces additional harmonic distortion. Therefore, addressing power quality now strengthens system resilience as loads continue to grow. It future-proofs your infrastructure against rising complexity and demand. Market projections reflect this shift. Demand for harmonic mitigation and power quality solutions is expected to grow significantly over the coming decade. Industrial and infrastructure leaders increasingly recognise that power quality is core infrastructure, not optional enhancement. As electrification accelerates, system optimisation becomes key to improving performance and efficiency. As your organisation becomes more electric and more automated, distortion within your network will not reduce on its own. The question is not whether power quality matters. The question is whether you can afford the hidden cost of ignoring it. Enginuity Power Solutions works with medium and large enterprises across Australia to diagnose, engineer and implement optimisation strategies that reduce wasted energy and strengthen system resilience. Because the cleanest, greenest and safest energy is the energy we don't use.